I was trained as what's called a developmental biologist, and my lab studied how a fertilized egg makes an animal. When our second child, Sam, was born, he didn't seem quite right, but at 6 months, so still as an infant, he was diagnosed with type 1 diabetes. So some people think it was a big deal for me to change my research to work on type 1 diabetes, but I did what any parent would do. When your child is diagnosed with a serious disease, you say, what am I going to do about it? After I learned about the disease, I discovered that for 90 some years, people had been injecting insulin and trying to figure out how much insulin to inject by measuring the amount of sugar in their blood. And as a biologist, I thought, well, if in the disease the problem is a cell is missing, why are we just trying mechanically to reproduce what that cell does? Can't we replace the cells?
If you had told me 30 years ago that you'd be able to understand well enough how to take a stem cell out of the body, turn it into islets, and replace the islets in a patient with type 1 diabetes, I don't think I would have believed you. This is a vial of cells made by Sema, the company that Doug Melton founded and Bastiano Sanna ran, that are stained purple because they make insulin.
That tiny little bit of cells, about the size of a pea, is enough to cause diabetes. It's the problem. But now we can make them.
I was a graduate student when I first met Doug Melton and watched him give a seminar on what he thought the future of medicine could look like, and was captivated by the idea that we could create living medicines if we could figure out the underlying cell biology. I remember the moment that we first tested these stem cell-derived islets in a dish and saw that we could stimulate them with glucose, stimulate them with sugar, and measure the amount of insulin they were secreting out of the cell. That was a moment where we knew we'd cracked some really important biology. And it was one of those moments that as a scientist, you never forget.
It took Doug Melton 20 years to understand how to make this. And it took the Sema team 5 long years to actually make more of these cells in a month than you can isolate from donors in a year in the US alone.
Sema was in a position at that time when they knew that these cells could serve to respond to glucose and make insulin.
I'm so proud of being part of that team, so proud of what we've accomplished. And I think that is because of all that hard work and that really honest look at the science that Vertex then got interested in what we were doing.
Yeah, Vertex likes to find an inroad where you know that if you did X, you would change a patient's life. And that made it a perfect match with Sema.
I feel very honored to continue to be able to contribute to moving this science forward. I think one of our most important roles in this is continuing to solve challenges, move roadblocks, really do whatever it takes to keep pushing forward to develop new therapies, because as anyone involved in drug discovery, drug development knows, it's really challenging.
It's very important to remember that we're not doing this ourselves. We're doing this with a whole community of, obviously, the community at Vertex, but also the community of doctors and caregivers, and most importantly, of patients and families.
We're really lucky to have an opportunity to engage with and speak with patients regularly. They are such an important part of our development program, and I recall just a couple of weeks ago speaking with a patient who said, I make 3 million decisions in 3 months to manage my disease. And that has really stuck with me, because I think often folks don't understand just how much of the burden of managing this disease sits on the shoulders of patients and their families and their caregivers.
If you're not a scientist and you have the disease, you want to know who's doing something about this. And I'm glad now I tell them Vertex. Vertex is going to do something about it.